Hi folks. So I have another lesson for you which is kind of like a continuation, part 2 of reaction coordinate diagrams. And last time we looked at exothermic reaction, and this time we are going to explore a little bit more information about an endothermic reaction. How is that going to be different from an exothermic reaction? Oh, right, let's look at that. Let's scroll down, and we have now a diagram where we have the reaction coordinate diagram for endothermic reaction. And how do we know that is an endothermic reaction? The way we can tell is because the reactants have less energy and the products have more. So therefore, energy has been absorbed by the system. Before, the energy was less, and now the energy is more in the system, and therefore this is an endothermic reaction. Well, we have the same parameters that we had last time: activation energy forward, activation energy reverse, the delta H of the system, and the transition state. And we are going to try to find out all of these pieces of information on this diagram. We're going to try to label it. So, first of all, activation energy forward is the amount of energy required to go from the reactants to the highest point on the energy scale. So, activation energy forward in this diagram would be right here. This is the activation energy forward, and you will see in this diagram the activation energy forward is much larger than the activation energy that we had for an exothermic reaction. And again, the reason is activation energy forward is the amount of energy that you need to have to go from reactants to the highest point on the energy scale, and that is in this case longer because this is an endothermic reaction. So we have found activation energy forward. Now, delta H of the reaction is the difference between the reactant and product energy, which would be this much here. That would be our delta H. And the activation energy reverse would be the amount of energy to go from products back to the reactants, so products to the highest point on the graph, which would be right here, and that would be the activation energy reverse, or EV, right? So activation energy reverse. So we have found all the 3 points. Okay, so the delta H we have the activation energy forward, and we also have the activation energy reverse. In this case, delta H is going to be positive. The reason for the positive value of the delta H is because the reactants had lower amount of energy and the products have high, and therefore the delta H in this case is going to be positive. Okay, transition state exists at the highest point on the graph, so transition state would be at this level, and the molecule that we have at this level is going to be called the activated complex. In both cases, exothermic, endothermic, it doesn't matter. The molecule is going to be called the activated complex state. So it is in the high energy form at this point on the graph. Okay, so that is all the things identified. We have the activation energy forward, activation energy reverse, the delta H, and the transition state. We have communicated information about all pieces of information there. Now let's go for the equation. Okay, to calculate the activation energy forward in this reaction, we will have to take the delta H of the reaction plus the activation energy reverse, right? So activation energy reverse, and this will give us the total amount of energy that we would need for the forward activation energy. If you can look from the graph, the delta H plus the activation energy reverse gives us the activation energy forward in the reaction. Okay, and if you want to rearrange that to find the value for delta H, the delta H is going to be equal to activation energy forward minus the activation energy reverse. All right, and so that will give us the value of delta H for this reaction, for this endothermic reaction. I hope you like this lesson and you are able to understand from this lesson what is activation energy forward, what is activation energy reverse, the delta H for an endothermic reaction, and the transition state slash activated complex, where transition state is the state or the energy level, and the activated complex is the energy or the molecule itself with that heightened amount of energy. I hope you like this lesson, and if you did like it, please hit like, subscribe, and keep on looking forward for new lessons coming up soon to help your understanding of the chemistry concepts.